Hey guys, this video is going to be going over power switching, which includes SSRs, SCRs, and contactors. Just as a refresher, power controllers are the output device that acts in response to a deliberate guidance from the temperature controller. In essence, we'll have the temperature controller, the power controller, and our heater. On our heater, we'll have a thermocouple situated somewhere in the bundle. That thermocouple will relay a temperature signal to the temperature controller. The temperature controller sends a signal to the power controller, which then switches power to the heater at the speed at which the temperature control tells it to. There are two main types of power switching, on-off and variable time-based. In on-off control, we utilize switched DC signals, or direct current, meaning the temperature controller will supply an on-off signal to the power switching device. The power switching device applies 100% power to the heater. Whenever the process has reached set point, however, it goes back down to 0% power, but takes some time to go back up and down between the power levels it's asked to do. In variable time-based, the temperature controller sends a 4 to 20 milliamp signal to the power switching device. This in turn converts it into how many power cycles it's on or off, supplying a tighter, quicker control to the heater. We'll begin by looking at contactors. A contactor is an electrically controlled switch used for switching an electrical power circuit. It would be wired from the power source into the heater and allows power to flow through at 0 or 100%. But let's see what goes on inside of it. We have our power lines coming in, and we have non-moving contacts. We would then have an armature with moving contacts and power going out. As you can see, they're not making any contact, so the circuit isn't completed. What we would need to do is take our positive and negative wires. It would be wound around an iron core that once electrified becomes an electromagnet. This attracts the armature, which then makes contact and completes the circuit. The pros of using a contactor is that they are less expensive and very useful in low amperage on-off systems. But because of their moving parts, they have a shorter life than most other power switching devices. They also switch very slow in comparison to the other power switching devices we'll be going over. Things to take away from a contactor is that they are cheap, but they're not necessarily the best. Next, we have SSR, which is a solid-state relay. It's a switching device that switches on or off when a small external voltage is applied across its control terminals. Unlike the contactor, there are no moving parts, so the power goes in and activates a diode. A diode's like a pathway for electricity. Power flows through and activates an LED, shown here. The LED turns on and emits a light. This light is picked up by what's called a photodiode. The photodiode takes light energy and converts it into a small voltage. That voltage is used to power yet another diode and send power out to the heater. To further isolate this light and to prevent accidental triggering of the circuit, they'll typically pour resin around the other non-moving components, just to isolate the photodiode and the LED. There are a lot of good points of using an SSR. It's the least expensive tight control power switch you can get. It has no moving parts and no mechanical failures, and thus it's noise-free. The cycle time is fairly quick at 5 seconds, which is why it's used for PID control, even though it's typically on-off internally. The cons are that it's weak to high ambient temperatures, so make sure that you use a heatsink if you use this. It can only switch lower amperages, but still this may be okay for some of your applications. It doesn't provide a positive circuit break on its own, so we have to rely on it not being jostled or moved around too much so that the isolation of the photodiode and an LED doesn't trigger the circuit by accident. You want to use this in a lower amperage system whenever you have an adequate budget and whenever you have small space, because SSRs are very compact. Lastly, we have the SCR. SCR stands for Silicon Controlled Rectifier. Its forward current between two electrodes is initiated by means of a signal applied to a third electrode, known as the gate. This sounds a little complicated, but once we see how it works, we can understand what it is. Three-phase power is supplied to the SCR, and three-phase power comes out and is supplied to the heater. but the rate at which it's supplied is determined by the 4 to 20 milliamp signal from the temperature controller. Here in this example, we can see 3 legs of power that corresponds to the 3 phases in our supply. So 3-phase power comes in to our internal SCR structure. Here we have a series of gates and diodes. A gate is a component that only requires a small amount of voltage to activate the diode and allow the current to flow. The rate at which it opens is determined by that 4 to 20 milliamp signal we were talking about earlier. It'll activate and allow the current to go through. So let's see this in action. We have our legs wired to our circuits, our gates are labeled. 3-phase power comes in. Let's see what happens to the first phase. L1 and L2 are activated. So then the controller opens up gates V1 and V5. The current flows through, hitting our heater, and is closed. Then on L2 and L3 are second phase. It goes through the heater again. V2 and V6 are the gates that are activated, and it's a closed circuit. Lastly, we have our third phase, L1 and L3. The gates V3 and V4 are activated, and it hits our heater. This is the efficient way that the SCR applies 3-phase power to our heater. And once again, it's all controlled by that 4 to 20 milliamp signal, and that's the rate at which it will switch all of these phases. There are so many good things an SCR can bring to your system. You have a wider range of firing options, switching options, and because there are no moving parts, there aren't any mechanical failures, and it will have a longer life. It has more accurate control because of those 3 pairs of gates and diodes that we saw. And then it also switches 3 AC wave cycles in less than 0.1 seconds. This makes it the most popular power switch for PID control because that is incredibly quick. The cons are that it's more expensive, but there are some lower amperage options that might be affordable for your customer. It'll be worth it in the long run. It is weak to heat, of which it produces a lot because of how fastly it switches. So we need a heat sink or some kind of method of keeping it cool. You want to use this when you have a higher amperage system, you need tight control, or it's a rapid thermal system. To sum it all up, contactors switch the slowest but are cheaper. SSRs switch pretty quick and are pretty moderately priced. SCRs can be more expensive depending on your amperage, but they have the tightest control and they switch the quickest. It all depends on what your customer's application is though, so don't try to go into an application with a bias on your favorite controller, even though mine's an SCR. We want to make sure that they're getting the right product for their application.